Hello and welcome. This is the AP Calculus AB and BC video for Units 2 and 3, Differentiation. This is part 2 in the series of 3 videos for these 2 units. The last video we looked at differentiability. This video we're going to be looking at the basic differentiation rules, such as the product rule, the quotient rule, and the power rule. And next video we'll look at more complex rules, such as inverse trigonometric functions and the chain rule. Let's get started. All right, so I have a list of the basic differentiation rules here. Don't be intimidated by them, there are pages. But they aren't that difficult. They aren't as hard as they seem. Right, so the first one is kind of a no-brainer, right? It's just telling you that if you multiply a constant by something else and take the derivative of it, you can just take the constant out and take the derivative of the part that has like a variable like x, right? So you just split it up, you take the constant out, you take the derivative of f of x, put the constant back in, right? Nothing to it. This is called the constant multiple rule, but it doesn't really need a name because it's just that simple. And here we have the power rule, right? This is going to be one of your best friends. Power rule is not that difficult as well either, right? You have this n here in the numerator, you just bring it down here, and then you subtract 1 off the n. So you get this n in the front, right? From that n you brought it down, and here in the exponent, it becomes 1 less. So x to the n minus 1. Right now, it is going to be pretty rare to just see like x to the n, but if you remember this other rule up here, the constant multiple rule, then say we have cx to the n, we want to get rid of that, we'd end up with cn times x to the n minus 1. It's a lot more useful with this because since you can like split up a function into different parts and then derive them from there, like adding or subtracting, you can now derive polynomials this way. We're going to do a bit of practice with that. And now the next one is the product rule, right? A bit more difficult, but not really that bad, right? We're just going to take the derivative of one of them and just leave the other function as is, and multiply those together, and then we're going to add that to take the derivative of the other one, right, plus the original function of that one, right? So for fx of g of x, we'd end up with f prime x times g of x, and we add that to v prime x of f of x, right? It's the same thing, right? Now we have the quotient rule, which looks a lot more intimidating, and it kind of is, but it's not that much more different than the product rule, right? So as you can see, the top part is almost exactly the same, right? It's just that in here we have this subtraction sign instead of an addition sign up here, right? So in the quotient rule, the numerator is the same thing as the product rule, except we subtract the part where we take the derivative of the denominator and multiply that by the original function in the numerator. And then we also divide by gx squared, right? The original function on the denominator, we square that, right? So that is the quotient rule right here. Let's go on to our second set, which is a lot easier. Right now, oops, error. All right, now we have technical difficulties. So the derivative of sine of x is cosine of x, as seen here, right? You have one trigonometric function, like the other one, right? Nothing to it, right? Like, while these ones were more rules about general functions, these are just like specific functions. What do you get when you take the derivative of them, right? So yeah, derivative of sine x is cos x. Derivative of cos x is not sine x, as it originally showed. It's negative sine x, right? And now those are some of our basic trigonometric functions. You can derive like tangent and cotangent out of these, right? Secant and cosecant we'll get to later, next video. Then we have the natural logarithm of x. Take the derivative of that, and we get 1 over x. As the derivative of natural logarithm of x is 1 over x. Now, one point that I did want to add in here is that if you take the like log, I don't know, base 10, right? That's pretty common. Log base 10 of x, right? Then take the derivative of that. You're not going to end up 1 over x. You're going to end up with 1 over x times the natural log of 10, right? Now you can see, right, if your base is e, right, like the natural logarithm, you're going to take natural logarithm of e, which is 1. So it simplifies to just 1 over x. But if you take it for different bases, it's going to be 1 over x, and also the denominator is going to be the natural log of the base. And the last rule is probably the one we all like the most, since it doesn't require like any work at all. Right? You get a function, you take the derivative of it, and it's the same function. The derivative of e to the x is e to the x. And similar to the how natural log of x work with different bases, it's going to be similar here, right? So if I took, let's call it constant c, right? It has to be a constant. C of x, I want to take the derivative of that. It would be equal to c of x times ln of c. Again, if the c is e, ln of e is 1, it all simplifies and goes back to this. However, the ones for different bases, right, these two over here, are not used that much, right? Like they're handy to know, but they just don't pop up that much. So that's why these main ones here are the ones you should remember, but these are handy derivations if you need them. But that's all of our rules. Let's get to just going through a bunch of problems, right? We do have a lot of problems, but they shouldn't be that difficult since, I mean, we get a function, you take the derivative, you just move on. All right, we started out with an easy one, right? So we can take this negative 19 away, put it back later. So e to the x, derivative of e to the x is just e to the x again. So we have e to the x, and then plus that negative 19. Isn't that nice? Same function we started out with. That was pretty easy, pretty quick. Keep going. Right, now we're adding two things, doesn't matter. Right, we can split it into the derivative of this part, and then add that to the derivative of this part. Right, you can do that for addition and subtraction. You cannot do that for multiplication and division. That's why we have a product rule and a quotient rule. Addition and subtraction, though, completely fine. All right, 7 cosine of x. So derivative cosine of x, negative sine x. Negative sine x. And then, that was a horrible n. Negative sine x. And then add back in the 7. And then here plus 3 e of x. So the e of x is going to also give us e of x. So another 3 e of x. Right, see, once you know the rules and you're able to apply them correctly, it's not that big of a deal, right? You go through them pretty quickly. All right, next problem. Right, a bit more complicated. Right, so we have this 2 cosine of x. So cosine of x is negative sine. So this 2 cosine of x is going to be a negative 2 sine x. Right, we can take the 3 in the next one. We can take the 3 out, and then we'd end up with 1 over x here. So 1 over x multiplied by 3. So this wouldn't be a 1 on the numerator, but a 3. Then we have the derivative of this constant. And we never discuss what the derivative of a constant is. And that's because it's 0. Right? Now, if, like, let's think about why this makes sense, right? If I have a graph, here's my graph, and the line of a constant, right, is just like this line. That's my constant. And it doesn't change, right? So if you try to do rise over run on this thing, right, the rise is 0, always. It doesn't matter how much you run, the rise is going to be 0. So there's going to be no slope, which means that your derivative is always going to be 0 because it doesn't change. So the derivative of constants are just 0. So our answer is just negative 2 sine x minus 3 over x. All right, let's keep going. Another one, we see that plus 11, right? We don't need it though because we know it's going to end up being 0. Now we can solve for the rest of it. So sine of x is going to give us cosine of x. Sine of x does not give negative cosine of x, right? You need to remember that sine of x gives cosine of x. Both of them are positive, but cosine of x gives negative sine of x, right? So sine of x gives cosine of x, so negative 4 cos x, and then minus 9 times ln x. The ln x would be 1 over x, and that would be 9 over x, right? Nothing to it. Let's keep going. Right, now we get what really is easier, right? So it's just like, it's just a power rule question, right? You bring the 5 down, and you get 5x to the what? Well, 5 minus 1 equals 4. So 5x to the 4. Right? Another one, right? Bring the 2 down, subtract 1, you get 2x to the 1, which is just 2x. And that one is also done. Another one, same structure, right? I think you're getting the hang of this now, right? So you put the 7, x to the 6th, right? I'll let you do this one. Right. But yeah, right? You bring down the 11, subtract the 1, and you should have gone 11 times x to the 10th power, right? All of these are just an application of the rules that we know, right? None of these have even utilized the product or quotient rule yet. So these are pretty simple, and like, yeah, as you've seen, they really aren't that much, and they kind of fall down pretty easily. Let's go on here, right? So we have the x to a negative exponent, and well, it doesn't really change anything, right? So it's still x to the n, right? Just that that n is negative, so we can still use the power rule, right? We bring the 8 down to get negative 8x, and then negative 8 minus 1 is negative 9. So now we get minus 8, negative 8 times x to the negative 9, and that's our answer. Make sure when you're dealing with negative exponents, you always clarify which direction the exponent goes in, right? You might be tempted to say, like, negative 8 times x to the negative 7, right? It makes intuitive sense if it was positive, not if it's negative, so don't do that, right? But yeah, it's just another application of the same concept. It also works for negative exponents, so yeah. And as we'll see, works for all exponents. It works for fractional exponents as well, right? We can bring the 5 over 2 down here, and then subtract 1 to give 3 halves. So our answer is going to be 5 halves times x to the 3 halves, right? It works for fractional exponents, negative exponents, all exponents. All right, now we're being asked for something different, right? We're being asked to evaluate these, right? The value of. We're not just being asked to find the derivative of x to the negative 6, right? Which if we did do, because let's get some more practice, we bring the 6 down, and we get negative 6 times x to the negative 6 minus 1, right? Not negative 5, negative 7. Though in this case, it doesn't really matter because we're just dealing with ones. But it's just a general precaution, right? It's better to be right. So you just put the negative 7 instead of the negative 5. Right? And this is the derivative, and we're asked for when x equals 1. So we plug in 1 in here, and we get 1 to the negative 7 is just 1, right? 1 to anything is 1. Negative 6 times 1 is going to be negative 6, and that question is done. Let's move on. Alright, we're trying to evaluate another derivative. So it's still the same power rule. We bring this down, and then we subtract 1. 1 half minus 1 is going to be negative 1 half. Right, so we're going to end up with 1 half times x to the negative 1 half. Alright, now what is 4 to the negative 1 half? Right, so if you remember, 1 half is like the square root. So this is going to be like this square root of 4 to the negative 1. And that just means the inverse. So 1 over the square root of 4, or 1 half. That's going to be this 1 half that we already have times this new 1 half. And that is going to equal, 1 over 4. Alright. That was not that hard. Let's keep going. Alright, now this question is seems difficult, but in reality it's just another power rule question. Since we can take this square root of 4 and make it x to the 1/4, right? So here the difficulty is not figuring out the derivative. The difficulty is transforming the function as something we can take the derivative of. Because from here, right, we just bring down the 1/4, we subtract 1, and then we get 1/4 x to the negative 3/4. And we are done pretty quickly with that. Let's keep going. Another one where we have to manipulate how the equation looks to figure out what we want. Right, so this 1 over x to the 11, right? So that's going to be the x to the negative 11, right? Because that x to the negative 1 inverts it, right? It puts what's in the numerator is on the denominator is on the numerator, it just flips it. So this is the same as x to the negative 11, and as we've seen so many times before, we bring that down, we subtract by 1, and we get negative 11 times x to the negative 12. Right? Let's go to another one. Right? Again, it's not about figuring out the derivative. It's about manipulating the equation. The square root of x, right? Is that, imagine we put a 2 right there. So it's going to be x to the 1/2. And by now you know the drill. I'll give you a couple seconds to figure out what that derivative is, right? But yeah, it should be 1/2 times x to the negative 1/2. And then of course we just plug in the numbers, right? This becomes 9 right here. And then 9 to the negative 1/2. That's going to be the square root of 1 over 9. 1/3. 1/3 times 1/2 is going to be 1 over 6. Alright, that one is also pretty easy. Alright, another one. So, let's stop for a moment, and I'll let you try to figure this one out on your own. Right? So, give you around 10 seconds. Alright. Tired of waiting for 10 seconds. So, yeah. So, with this x squared in the denominator, right, we can pretty easily make that x to the negative 2. And from there, we do all of this stuff. Right? Now we get minus 2 times 5 to the negative 3. So 5 to the negative 3 is going to be like 1/5 to the third. That's going to be 1 to the 3, which is 1, over 5 to the 3, which is 125. So it's going to be negative 2 right here, times 1 over 125. Negative 2 over 125. And that is done. Alright. Now we're going to be getting more into taking the derivatives of more like polynomials, right? And this is not a polynomial by any means, since we have like a sine function, but it's the same principle, right? We're still using the like sum or difference rules that we also used at the beginning of this whole slew of problems, right? Now, of course, not that much to it. We can split it right. We can split it right here in between. Oops, did not mean to move it. Let's split it right here in between these two, and the derivative minus 4x cubed is going to be minus 12x squared. Minus sine x is going to give you minus cos x. Remember, sine x gives cos x, but cos x gives negative sine x. That's going to be negative 12x squared minus the cosine of x. And that is our answer to that question. All right. Next question. All right, kind of the same thing, right? We split it up right here. 7 sine x is going to be like 7 cos x. And then here, this part right here becomes, bring 3 down, so we get negative 6. Let's subtract 1 from the 3, and we get x squared. X squared. So 7 cos x minus 6 x squared, and that is our answer. Right? Right here is another easy one. Let's split it right here. And most of the challenge on these is trying to figure out where to split it. Right, you can split it right here. Right, as always, just this is a difference here. Even if it was a sum, you can just split it up. Right, there's no complicated rule like the product or quotient rule that you have to apply here. Right, so you take this minus 8x, and it becomes minus 8. You take this minus cos x. Here's where you have to be careful. Cos x by itself will give you minus sine x. And then you're taking the negative of minus sine x, and that would give you positive x. Positive sine x, sorry. Positive sine x. You end up with negative 8 plus sine x as your answer. Alright, so here we are on the last problem, and I'll give you some time to try to figure it out on your own. And same concept as all our previous problems, just splitting it up, solving them individually because the sum or difference, right? I'll give you some time to figure that one out, right? Of course, you can pause the video if you want to. And all right, so see what we have here. Right, we can draw our line right here. This becomes right. We bring the 2 down, we get negative 10. We subtract 1 from the 2, we get 1, so that'd be minus 10x to the 1. Of course, the 1 usually just exclude it. Minus 10x. Again, we have the derivative of a negative cosine of x. Right, we can take this 4 out for a second. Derivative of negative cosine of x. Cosine of x is negative sine x. So negative of a negative sine x will be a positive sine x. Positive sine x. And then you're going to also have that 4. So it's going to be minus 10x plus 4 times the sine of x. And that is it for this video. Right here we learned all the basic differential rules, right? How to differentiate polynomials, how to differentiate trigonometric functions, logarithmic functions, and we went through lots of problems on those. Right, next video we'll come back to do some more advanced differentiation rules, including the chain rule as the one we're going to use the most, but we're also going to use, say, the inverse function rule and the inverse trigonometric rules. Right, stay tuned for that, and I'll see you next time.